Okay, we'll resume from this slide. I was telling about some of the introduction here. So um, we're going to know what's digital contact tracing is. So this is a method to record and track close contacts between individuals as well as protecting their personal information. Use of cross-blockchain technology, such as the interoperability feature of the Polkadot network, which we'll see in the next slides, allows for the creation of a decentralized and distributed contact tracing system that can be used by multiple organizations. So cross-blockchain technology could be used as a tool to help slow the spread of infectious disease and assist in contact tracing efforts. My research can contribute to this field by identifying ways to standardize and improve interoperability between different blockchain networks. So now, with that being said, let's see what's blockchain is and see some background knowledge. So blockchain is a digital technology that allows multiple parties to share and manage information in a secure, transparent, and decentralized way. It is best known as the technology behind cryptocurrencies like Bitcoin, but it has many other potential use cases as well. A simple analogy is to think of it as a digital ledger that is shared among a network of computers. Each entry in the ledger, called a block, contains information such as a transaction or other data. These blocks are connected together in a chain, creating a permanent and unchangeable record of all information that has been added to the ledger so far. So because the ledger is now distributed among many computers, it is extremely difficult for any person to change or manipulate the information, and this makes it very secure and transparent. Additionally, because it is decentralized, no single person or organization has complete control over the information, making it more democratic and fair. So now what's cross-chain technology? New blockchain implementation these days with more functionality are being developed, and developers are kind of struggling to track blockchain progress and find the best solutions that suits their needs. So blockchain interoperability can solve this issue. The cross-chain protocol makes it possible for data to be transferred across several blockchains and improve overall network efficiency. Cross-chain protocol lets users communicate directly, and assets and data may be moved freely across blockchains that use the same or different networks. Now, building on what we just discussed, let's see what Polkadot is. Polkadot is a blockchain network that allows multiple blockchain networks called parachains to operate together in a decentralized and secure way. It is designed to enable interoperability, scalability, and governance across different blockchain networks, allowing them to work together seamlessly. Again, here, a simple analogy to explain Polkadot is to think of it as a highway for different blockchain networks to connect and communicate with each other. Each vehicle on the highway represents a different blockchain network or parachain that can operate independently, but also share information and resources with other networks as well in the highway. So Polkadot's main goal is to create an ecosystem of interconnected blockchain networks that can work together in a decentralized and secure way. So that is, so it will bring new use cases and solutions that were not possible, maybe not possible before. So now to continue, let's see some related literature in the field. The first one, authors wanted to answer this question, whether it is possible to develop and implement a system running on blockchain for keeping the health records across hospitals and sharing them simply without any privacy links. But although blockchain provides us unique opportunities to increase the healthcare system's treatment and diagnosis efficiency, still certain challenges are in place. So the second one aims to introduce and review blockchain technology to the biomedical and healthcare areas, including its merits, drawbacks, and most recent applications. No previous works on before the third reference or literature examines the role of future technologies like IoT, UAVs, AI, blockchain, and 5G to manage COVID-19 pandemics, a pandemic and the pandemic likes. So the authors of the third offer a complete assessment of the COVID-19 pandemic. Now, some of the previous main works include Singapore Trace Together, Google or Apple contact tracing, UK NHS contact tracing app, and China health code system, which the first three solutions use Bluetooth technology with a high power demand because the user should keep the device in an active broadcasting mode, and all Bluetooth-based contact tracing systems are subject to threats such as spying, sniffing, and jamming due to vulnerabilities. China Health Code works by scanning a QR code connected with user, but because of the centralization of the system, user's privacy is not protected and user's identity is not hidden from the authorities. Authors of the next article introduced a system called BipTrace. BipTrace uses many technologies like GPS, Bluetooth, cellular, and Wi-Fi, which brings us medium power usage, high security, and privacy-preserving features, yet the limitation is reaching particular groups of people, the matter of scalability. And the two last, but obviously not least, are describing the digital contact tracing technique and the application built so far to track the COVID-19 like pandemics. Scalability issue in terms of the total number of active cases is among the challenges here in the 7 reference, and a huge platform in the 8 reference introduced, which uses blockchain technology to create a transparent health record chain. The suggested approach is also patient-centric, meaning the patient has control over their own data. And I'd like to highlight my own contribution to the field. This is my published paper in 16th International Conference on Blockchain and Cryptocurrencies held last year, June at New York. So let's shift our focus now to what the current situation is and what's wrong with it, what needs to change. The COVID-19 pandemic, we know that has paralyzed many lives until a vaccine has been available, which caused the so-called new normal, and governments and health officials tried to impose rules and regulations, and software engineers worldwide developed applications to trace and track patients' movements and notify others. So because most of the application uses technologies that can potentially reveal the user's identity and location, researchers have debated privacy preservation and how to improve users' privacy during such pandemics. So now, thanks to distributed ledger technology, there have been some proposed methods to develop privacy-preserving patient tracking systems in the last 2 years. In terms of significance and sense of urgency, blockchain can potentially transform the healthcare industry. Confidential and authorized data can be exchanged securely through this method. In a blockchain consortium, any healthcare organization can share medical information independently of the system it uses for its native electronic health record keeping. So we found that 2 major obstacles facing blockchain implementation across many healthcare systems are scalability and privacy. Now, the purpose of this study was to investigate the solution for an effective global contact tracing system by leveraging cross-blockchain technology to achieve interoperability and scalable digital contact tracing across various jurisdictions. So here, moving to methodology, um, we offered using a framework of heterogeneous contact tracing, using cross-blockchain technologies to increase this global availability. This figure shows a relay chain block of a Polkadot network, which I could say, or I may say, was invented and introduced by Dr. Gavin Wood in 2016. So this is the main chain of the Polkadot network that is responsible for coordinating different parachains. We can see 8 parachain blocks, which are individual chains that run parallel to the relay chain and can be customized. Now here, each parachain has 5 collators and 3 validators assigned to them. These are like for validating and controlling transactions. We have the bridge protocol here that is a sub-protocol that lets Polkadot work with chains from outside the system. And this figure shows the relay chain with 4 relay chain blocks. We have blocks that are like relay chains and connected together with hash, like in a legacy shape of the blockchain. So let's see how to develop such application. Building a blockchain is a difficult process, but here with the Substrate software development kit, offer the core components a blockchain needs so we can concentrate on developing the logic that makes our chain unique and interesting. Substrate has chosen Rust language as its primary language because it's fast and reliable. It's a safe option. And Substrate nodes at a high level provide a layered environment composed of 2 primary components. One node is the one that is on the network's edge, responsible for tasks including peer discovery, transaction request management, peer consensus, and remote procedure call handling. The other one is a runtime that implements the blockchain state's transition function and provides all the necessary business logics to do so. So with Substrate, we have complete creative control over the application we want to build. We can select predefined application logic from a large library of open source modules and templates, or also there's an opportunity to build custom modules from reusable Rust macros and codes. So I have personally compiled and deployed common modules to mimic the use case and added a few existing palettes or modules. We call modules palettes in Polkadot. And I have also investigated and built a custom palette for contact tracing. So here we can see the sequence diagram of the potential use case that we were talking about so far, where user can interact with the application and send, for example, his or her postal code. Then the application is encrypting the data and sending it to the blockchain network, which is storing our states. Then our state transition or runtime, which has our logic, verifies and stores data, do needed calculations, and send back the updated states to the blockchain network. And at the other hand, we have health authorities, which can query the contact tracing data, the blockchain, and receive required data to identify the spread of any infectious disease. We also use Polkadot.js and Substrate frontend template to build and actually show the functionality. Polkadot.js provides us with an API to query a node and interact with the Polkadot or Substrate chains, and also Substrate frontend template is frontend that interact with the nodes using a web browser interface. What we see here is the Polkadot.js dashboard. It has many Functionalities and options, we can see chain info, what are the recent block addresses, and just we can see other, as we can see in other tabs, we can see block details, what are other states. Moving forward, this is the template that is interacting with the web browser. We can see that there is different modules here. For example, for upgrading runtime, we can upload a WebAssembly file here, or a transfer module, the balance module. There are different modules. So when we clone them, they are present here and we can interact with them. This is the second page of that template. This is pretty much the same. We have all functionalities that we want. So in terms of results, we have three key parameters to compare the results. One is transaction per second parameter, which is this metric indicates the throughput or performance of a blockchain system. So higher throughput or a higher transaction per second means higher scalability, as it implies that system can handle more transactions without compromising the security or decentralization. Polkadot might reach to a 1 million transactions per second as the network expands and parachains are added continuously, while Ethereum can process up to 100,000 transactions per second. Energy consumption is the other metric that is indicating the efficiency or sustainability of a blockchain system. So the lower, the better, as it implies that the system can reduce its environmental impacts. Polkadot consumes a small fraction of the energy used by blockchains thanks to its proof of stake consensus mechanism. And the other metric is interoperability level. This metric indicates the degree or quality of interoperability between different blockchain systems. So the higher, the better, as it implies that systems can achieve more complex and meaningful interaction. So as we've been through now, Polkadot has a high interoperability level thanks to its relay chain and parachain architecture that allows for cross-blockchain transfers of any kind. These are other metrics that our results are built on. So Polkadot's unique architecture allows for multiple parallel chain, each with its own security feature. So this provides us a more resilient system. Another one is the shared security, which means that all parachains on Polkadot benefits from shared security as they are all secured by the network's validators. We have on-chain governance, which means that Polkadot's on-chain governance system allows for community-driven decision-making, so ensuring that any changes are made in a transparent way. And it also keeps privacy and interoperability as of the ability to create private or confidential transaction, as well as the option to keep certain data hidden from the public, and the ability to connect with other blockchain networks via its cross-chain message system. So allows for the secure and private transfers of asset and data between different networks. So compared to the other blockchain-based contact tracing app, a Polkadot-based app could potentially provide the following advantages. The first is scalability, as we've been through. Because of its unique architecture, it brings us a true interoperability, as mentioned earlier. And also customizability, as Polkadot allows for customizable blockchain design, which could allow for the creation of a contact tracing app that fits the specific needs of a particular jurisdiction. So moving on to the next point, there are some limitations to using Polkadot now to develop contact tracing app. So still, it is relatively a new platform and hasn't yet been fully tested in a production environment. It may not be able to handle the large amounts of data that contact tracing applications would require. Still, adaptation can be a challenge to achieve a critical mass of users for a new platform like Polkadot. Developing a contact tracing application on Polkadot would require a deep understanding of platform and its unique features. So the complexity and substrate palette limitations is another challenge, which developers may need to build custom palettes or modify existing ones. And there may be also a compatibility issue when integrating palettes from different sources or with other blockchain systems. Now, and to conclude, other than health industry, contact tracing can be used in several other applications, including supply chain management to trace the origins of products and raw materials, environmental monitoring to track the movement of wildlife, food safety, logistics and transportation to track the movement of vehicles and cargo, fraud detection and cybersecurity to track the movements of suspicious activity or suspicious activity or patterns of illegal activity, and social media or human resource management to identify source of misinformation or monitor the attendance, performance, and movement of employees. These are the references, and thanks for your time.